All right, this section's a few other facts about Diels Alder, and I mentioned this earlier, retrosynthetic analysis, or in other words, taking it back apart. And again, this is pretty simple. If we have a Diels Alder product and something just occurred to me that I did not cover in the last section, I do not remember seeing it as an option. Anyway, what's going to be obvious as a Diels Alder product is you're going to see that six-sided ring with a double bond over here. Now, the reason I just said what I did is that it's possible for there to be a double bond right here as well. And I need to look back and see why that wasn't covered. I may have just skipped over it inadvertently. But the dienophile can have a triple bond in it. And when it does, then you end up with a double bond right here. So I'm going to backtrack and look for that here in just a minute. Anyway, so here's an obvious Diels Alder adduct. Six-membered ring, double bond on this side. So you know that what you're dealing with is those six bonds and that pi bond right there. So you just move them back where you know that they came from. Take the sigma bond up here, move it over here to make a pi bond. Take this sigma bond down here, move it over here to make a pi bond, and then move this pi bond up to here. And there's what you get. In other words, this was your diene and this was your dienophile that came together to form this Diels Alder adduct. So taking them back apart is just about as easy as figuring out how to put them together in the first place. Might consider this a little bit harder to see, but 1, 2, 3, 4, 5, 6. Even though we have this sort of basket shape, there's still a six-membered ring here with a double bond at one side. And so you still just turn the sigma bonds here to a pi bond here moves over to here. The sigma bond here becomes a pi bond right there. And so that's what you started with. I don't remember us doing much with this either. So I may have skipped some things. I will go back and see if that needs to be addressed. Pufferfish and the tetrodotoxin that they produce. And let's see. Here are a few for practice. This is where I'm thinking it might be good if I drew these out, but I think it's pretty obvious. I hope you do. Here's our six-sided ring. So I'm going to take this sigma bond right here. I can't get this pointer to move the way I want it to. And I'm going to move it over to here to become a pi bond. I'm going to take this pi bond and move it up to here. And I'm going to take this sigma bond here and move it in to be a double bond right here. And that will separate them. Okay. So here again, retro Diels Alder. Some of these are a little bit harder to see just because our diene here, which is locked into S-cis because of it being part of a five-membered ring. Of course, that makes it extra reactive. And over here, our dienophile is the same thing. And we get dicyclopentadiene. Formation of dicyclopentadiene is so rapid it takes only a few hours at room temperature for it to completely dimerize. So, dimer, hopefully you're familiar with the terms monomer and polymer, and a dimer just consists of two units. So what we've done is we've taken two cyclopentadiene, I think the 1,3 is redundant, not necessary, but two cyclopentadienes, and they react with each other in a Diels Alder manner. You get the dicyclopentadiene, which is a dimer. When heated, it will undergo a retro Diels Alder reaction, and you get two molecules of cyclopentadiene reformed. If it is immediately treated with a different dienophile, then it will react and form a new Diels Alder product. So we can throw in a different dienophile to get a different product. All right. Making steroids. Here's the skeleton of steroids. These 4 rings labeled A, B, C, D. There's a 3D view. And then if you view that from the side, you can see that everything is not coplanar. Now, steroids, sometimes the word steroid gets a bad reputation because we tend to only know about it from bodybuilders and athletes abusing certain types of steroids. But you have a lot of hormones that are in your body that your body makes that are classified as steroids. They're made from cholesterol. Here's a couple of them: estrone, which is one of the female sex hormones, and cortisone, which comes from the adrenal cortex. And if that ketone group, I forget exactly which one it is, I would have to look. You've got multiple ketone groups in this. One of those gets converted to a hydroxyl group, and then you have cortisol, or maybe 2 of them. I don't remember. I always have to look those up. Anyway, they show how Diels Alder reactions help to create those. All right, what else? I believe that is it for this section.